Good day, young geniuses. My name is Teacher Michael, and I will be your learning from home tutor for today. How are you right now, class? It's good to know that all of you are doing fine, good, and great. And I will make that even better because of our interesting lesson for today. All right? So before we formally begin with our lesson for today, let us first remember what we have discussed last time. It's all about adding similar fractions. But can you still identify similar fractions given the set of fractions? Let's see. Through this activity entitled Similar Fraction or Not. So I will be presenting series or sets of fractions on my screen. Then you have to identify whether it is a similar fraction or not. If it is a similar fraction, you just have to raise your hand with a thumbs up. And if not, you just have to raise your hand with a thumbs down. All right? Can I see a raise hand button if you understand the instruction? Okay, let's begin. Number 1, similar fraction or not? I can see that all of you answered thumbs up. Then it is a similar fraction. Why do you say so? All right, because they have similar denominator. So it is indeed a similar fraction. Always remember that similar fractions always have same denominator. Now, let's try to find the sum of the given fraction that you have guessed a while ago. 2 sevenths plus 4 sevenths is equal to, very good, 6 sevenths. Wow, you still remember our discussion. So let's try it more. Next, similar fraction or not? Spot on. All of you answered correct again. And it is indeed a similar fraction. So let us now find the sum. Wow, amazing. 11 over 13. So now let's begin to this item. Is that a similar fraction or not? I can see that all of you answered thumbs down. Why do you say so? Indeed, because fractions with different denominator is what we called as dissimilar fractions. Now, do you know that we can just add instantly dissimilar fractions that we usually do in similar fractions? That's why we have to do something first before we can perform an operation. In this case, before we add the fractions. All right? I know that there are questions that may arise in your head. And one of this is this on my screen. How should we add the similar fractions? Let's see. Oh, the similar fractions use least common denominator or LCD of the set of fractions to transform them into similar fractions. Basically, we are going to transform the two fractions with this we classify them as dissimilar fractions into similar fractions so that we can perform an operation or we can add, subtract them. So we use a least common denominator. But how to find this common denominator, LCD of the set of fractions? But first, let us first define the least common denominator so we can get through with that and find the answer to the question that presented on the screen a while ago. Definition of least common denominator is that it refers to the least common multiple of the denominator of the set of fractions given in a expression. As you notice, I highlighted the word least common multiple. Sounds familiar, right? Because we have tackled that last few weeks ago. And this topic is very important, and this least common multiple is very important to find the least common denominator of the series of fractions. So we can infer that to identify the least common denominator, you have to find the least common multiple or LCM of the denominators in the set of fractions. So let's try it with our example that we have a while ago, 1/4 plus 1/2. So first, we have to find the LCD. And to find the LCD, we have to get the what? We have to get the least common multiple of the denominator. So can you tell me what are the denominators in the set of fractions? Very good. It's 2 and 4. And now that we already identified the denominator, we should do the least common multiple. And one technique that I taught you out last few weeks ago is the use of listing technique. So how do we do that again? We are going to list the multiples of the numbers. Like for instance, in our case, we are going to use 2 and 4. So let's start with 2. 2, 4, 6, 8, 10, 12, and so on. And how about 4? The multiples of 4 are 4, 8, 12, 16, 20, and 24, and so forth. I just identify for 6 multiples of 2 and 4. Now, can you see any common multiple in both 4 and in both 4 and 2? What are those? Very good. You saw it correctly. It is 4 and 12. That's why there are 2 common multiple in the first 6 multiples of 2 and 4. Now, the one that we are going to find is least common multiple. Which of the following common multiple has a lower value? It is indeed 4. That's why our least common multiple is 4. Thus, our least common denominator for 1/4 and 1/2 is 4. So the LCD that we are going to use is 4. Now, let's proceed to the second step. Once we already identified the LCD, we are going to transform each fractions into its equivalent fraction, if applicable. Later on, I will discuss why if it is applicable, why I put up if it is applicable. Okay, now, in transforming the original fraction into its equivalent fraction, we have to respect our LCD. That's why we are going to base our equivalent fraction based on the resultant LCD, the LCD that we got from the denominator a while ago. So our LCD is 4. That's why we are going to base our equivalent fraction to the LCD, which is 4. So here are the steps. First one, you have to divide the LCD to the original denominator. Then after that, the result will be multiplied by the numerator. So like for instance, if we do the step, what will happen? 4 divided by 4 is 1, multiplied by 1 is 1. How about this second one? 4 divided by 2 is 2, multiplied by 1 is 2. As you have noticed on the first fraction, it did not change. Why? Because the LCD is as same as the denominator. So with that, we are not going to change that anymore because the denominator and LCD are the same or common. That's why the result is 1/4. That's why I said a while ago if it is applicable. So if the denominator and LCD of the original fraction is just the same, you just have to write it down again. All right? How about the second fraction? 1/2. It changed to 2/4. So how this will imply? 2/4 is as same as 1/2. If we get the LCD of 2/4, it will result to 1/2. That's why 2/4 is an equivalent fraction of 1/2, or vice versa. 1/2 is the equivalent fraction of 2/4. That's why they are equal. Let's go to the next step. Our last step is that we are going to add them. Why? Because the denominator now is similar. And we are now finished in transforming them into its similar fraction. That's why we can now add them. So how we're going to add similar fractions again? 1 plus 2, which is the numerator, is equal to 3. And copy the denominator. That's why the result is 3/4. How about the 1/4 plus 1/2? What will be the result then? It's also 3/4 because again, 2/4 is just an equivalent fraction of 1/2. All right. Now let's try another example so we can practice ourselves in adding the similar fractions. Let's try this one. 2/3 plus 1/4. First step, let's find the least common denominator. What are the denominators in the set of fractions? We have, very good, 3 and 4. Then second, we are going to find the least common multiple of the given denominator, which is 3 and 4. So what are the common multiples of 3? Let's have the first 5. 3, 6, 9, 12, 15, and so on. How about 4? 4, 8, 12, 16, 20, and so on. Is there any common multiple? Very good. What is it? What is it? It is 12. That's why our common multiple or least common multiple is 12. Thus, our least common denominator is also 12. Now, for our second step, we are now going to transform the original fraction into its equivalent fraction. Okay, so let's now try it. First original fraction, 12 divided by 3 is 4. 4 for the result. Then 4 multiplied by 2 is what? 8. Very good. How about this one? The second original fraction. 12 divided by 4 is what? 3. Multiplied by 1 is also 3. All right. Now, are we finished transforming them into similar fraction? Yes, we already transformed it. What will be the next step? We are going to what? Find the sum. So 8 plus 3 is equal to what? Is equal to 11. Then what about the denominator? We are going to copy them. That's why the result will be 11 over 12. Okay? Again, the result is 11 over 12. How about this 2/3 plus 1/4? It is also the same because we just transformed them into their equivalent fraction with respect to our least common denominator. All right. With that, can I see the raise hand button if you understand the steps in adding dissimilar fractions? I can see none. So let's practice. Find the sum of the following set of fractions. There are 2 items. You have to do that in your papers. I will give you 5 minutes to answer this 2 items. Timer starts now. All right. All of you are already done. Now let's answer the 2 items. First one, 1/3 plus 1/2. So first we're going to find the LCD. What is the LCD? What is the LCD? It's 6 because the denominator is 3 and 2, and we're going to find the LCD. It's 6. All right, very good. Now transform them into equivalent fraction. First, the 1/3. What is the answer? We have, very good, 2/6. What about the 1/2? Very good, it's 3/6. So add the similar fractions. The answer will be 5/6. How about number 2? What is the equivalent? What is the LCD? It's 21. Now, divide the LCD to the original fractions to find the equivalent, to transform it into equivalent fractions. Very good. It's 14 over 21 or 14/21. How about the second fraction? Good job. It's 6 over 21 or 6/21. What will be the sum? It's 20/21. All right. So good job. I can see that all of you answered it correctly. Now, let's summarize our lesson for today. In adding dissimilar fractions, first, you have to find the LCD. And in finding LCD, you have to what? You have to identify or find the LCM or least common multiple of the denominator of the set of fractions. The second step, you are going to transform the original fractions into its equivalent fractions in respect to the LCD that you have just identified in steps 1. And last step, we are going to add the transformed equivalent fractions and find the sum. Then there you have it. We can now add dissimilar fractions. Do you have any questions? Don't be shy. I can answer you politely. And class, please respect the ones who asking questions, because you are just being curious, and curious is good. Curiosity is good to your brain. I can see that all of you don't have any questions, so I guess you really learned a lot today. With that, let's call this a day. Goodbye and thank you, young geniuses. See you tomorrow.